All right, so we're going to talk about stoichiometry today and go over what you can figure out from stoichiometry. So first and foremost, what you need to start with in stoichiometry is a balanced chemical equation. You practice balancing, so I know you can do it and everything will be fine. From that balanced equation, you can marry the mole facts with one more conversion fact, and you can find and predict the amount of product that is made in any equation, the amount of reactant you need, and it gives you just a boatload of information. So we're going to be using one more ratio, and that is off of the moles of each part of a balanced equation, and we're going to use the coefficients as the ratio. So it's easier to show than tell, so we'll go right into the showing. So I have given you here a recap of how to do dimensional analysis. I've given you the mole facts and then one more bit of information. You are going to use the coefficients from the balanced equation to jump around in the balanced equation. Here's what I'm talking about. Our first example is a mole-to-mole problem. Here's our balance equation. And it says how many moles of oxygen gas are required to react completely with 10 moles of hydrogen gas. Using our dimensional analysis, this is what we're going to do. I'm looking for the problem, and my wanted is how many moles of oxygen gas, and my given is 10 moles of hydrogen gas. Now, this is a very elemental problem. All we have to do is switch from talking about hydrogen to talking about oxygen. To do that, we are going to use one more equality. Using the coefficients, we know that 1 mole of oxygen gas is the same as using 2 moles of hydrogen gas based on the stoichiometry of this reaction. Multiply everything on the top divided by the bottom, and you have your answer. One extra step is needed if you're going from mass to moles. So this time it says if 27 grams of hydrogen gas react with an excess of oxygen gas, how many moles of water will be produced? Here is our balanced equation. We're going to start with the grams of hydrogen gas. We're going to convert that to the moles of hydrogen gas, and then we're going to use stoichiometry to start talking about the moles of water. The moles of water is equal to 27 grams of hydrogen gas. According to my balanced equation, there are 2 grams of H2 for every 1 mole of H2. I now use my coefficients to go from hydrogen to water, and here is my answer. Here is a clue to you. You will only use a number other than 1 when you write moles, when you're switching from one part of the equation to another part of the equation. When you're talking about the same reactant or product, it's 1 mole equals the molar mass in grams. 1 mole equals 22.4 liters of gas. 1 mole equals Avogadro's number. Good? And here would be the longest type of problem that you would use in a stoichiometric problem, is a grams to grams. It's going to require 3 steps. I would like to, if I still have that 27 grams of hydrogen gas and it reacts with an excess of oxygen gas, what mass of water will be produced? I'm given 27 grams of hydrogen gas. I want to know how many grams of water that is. I need to convert the hydrogen gas to moles of hydrogen. Then I do my switch step, moving from one part, hydrogen, to another part of the balanced equation, using the coefficients. Then, now that I'm talking about moles of water, and then molar mass of water, and so that gives me the answer of 243 grams. Turn your paper over. I'll do one problem with you, and then I'm going to section 3. Okay, we're going to practice a mole-to-mole problem, a mole-to-mass problem. How many grams of oxygen gas are required to react with 2.2 moles of NO in the production of nitrogen dioxide gas? So the first thing this requires is an equation. The second thing it requires is a balanced equation. So I'm going to see what they tell me. And they tell me how many grams of oxygen gas are needed to react with nitrogen monoxide in order to produce nitrogen dioxide gas. So far, so good? All right, now I need to balance it. It's not balanced now. I think if I do this and this, I'm good. All right. Now, this is my unknown, this is my known, and I'm going to set this up dimensionally. The number of grams of oxygen gas equal to 2.2 moles of NO. Who can tell me what my first step is?
Coefficients.
Okay, and I'm going to use the coefficients to go from what to what?
Nitrogen.
Monoxide to nitrogen.
To
Oxygen.
moles of oxygen. And just inserting the coefficients, I get this. My next step would be then to convert the number of moles of oxygen gas using its molar mass to grams of oxygen. 1 mole of O2 has a molar mass of 32 grams. These cancel out, these cancel out. I know I'm done when these are the same, and they are. I do some math. Here is a clue for you. The sig figs are ruled by the number of sig figs in the known in your problem. These are all exact numbers. They do not play in significant figures. 2.2 times 1 times 32 divided by the quantity 2 times 1 is 35 grams of oxygen gas that are produced. Okay.